Nice having you once again, my wonderful scholars. JAMB past question 2001, question number 25. The diagram below shows three capacitors, C1, C2, and C3, of capacitances 2 microfarad, 6 microfarad, and 3 microfarad, respectively. The potential difference across C1, C2, and C3, respectively, are. Our question today is centered on capacitance of a capacitor. Capacitance of a capacitor. Taking a careful observation of the diagram, we'll be seeing the capacitances C1, C2, and C3, and the total voltage, the source of energy, 12 volts. And the question is demanding for the potential difference of voltage in the individual capacitors. Recall, a capacitor is a circuit component that stores electrical energy in electric field. A capacitor is a storage circuit component. It stores electrical energy in electric field. Another thing to remember before we can tackle the question X, arrangement of circuit components. We've said before now, I was saying now that anytime we have series connection or series arrangement, current or charge is the same throughout the circuit. The current or the charge remains the same, whereas the voltage varies. You can observe what will have a series connection of capacitors. Therefore, the current, or rather the charge in the circuit is the same, but the voltage will vary. Okay, observe from the diagram. We have 2 microfarad capacitance, 6 microfarad, and 3 microfarad. The voltage in each of the capacitors will change, whereas the charge remains the same. Therefore, to find the voltage in C1, the formula for finding voltage under capacitance, the capacitance of a capacitor is equated as C is equal to Q over V. You can see from the equation that the higher the capacitance, the lower the voltage. Whereas the higher the voltage, the lower the capacitance. The capacitance of a capacitor and voltage are inversely proportional. When capacitance is going up, the voltage is going down. When voltage goes up, capacitance of a capacitor goes down. Inverse proportion. Okay, that's what we've stated there. But the question is demanding for voltage or potential difference in each of the capacitor. Therefore, let's make the voltage the subject of the formula. V becomes equal to Q over C. These are targets. So we'll bounce back to our circuit diagram to get the voltage here. Since this is C1, we'll call it V1. V1 will be Q over C1, following the formula. Notice that the Q has no 1. Recall, in series connection or series arrangement, the charge is the same. Therefore, this charge is the same. The charge in capacitor 1 is the same as the charge in capacitor 2. Likewise, capacitor 3. The charge is the same throughout the circuit. Why? Series connection. Okay, so the voltage in capacitor 2 will also be V2 equals Q over C2. Voltage in capacitor 3 will be V3 equals Q over C3. Notice that Q in all the capacitors is the same. This is series connection. Okay, then to find the voltage in capacitor 1, we have our C1, but we don't have the charge. In 2, we have C2, we don't have the charge. Voltage in capacitor 3, we have the C3, which is 3 microfarad, whereas we don't know the charge. So we have two unknowns. We don't have the voltage yet, and we don't know the charge. Therefore, we must go and find the charge before we can find the voltage in each of the capacitors. We must find the charge first. Then to find the charge, what do? We place maths. How do we place maths? Let's go and make charge the subject of the formula. This is capacitance. The question is centered on capacitance of a capacitor, so we'll focus on this equation. So to get the charge, make Q the subject. Q becomes equal to CV. That's how to find the charge. Then to get the total charge in this circuit, we must know the total capacitance and as well the total voltage. Okay, let's see if we know them. Then the total charge is equal to the total capacitance. We don't know yet. we have three capacitances. So we'll get effective or overall capacitance. Okay, then we'll call that CT. Then the total voltage we know. We're not talking about the individual voltages. We're talking about the total voltage in order to get the total charge in the circuit. Then that is 12 times 12. So I have two unknowns. I can't get my charge yet. To get the charge, I must go back to my equation to resolve the three capacitances to get a single capacitance that will have the same effect as those three capacitances. Then the question becomes, what arrangement is this? This is series arrangement of capacitors. Okay, to get the total capacitance, we will record that in series connection of capacitors. We follow the pattern 1 over CT is equal to 1 over C1 plus 1 over C2 plus 1 over C3. This is series arrangement of capacitors. Series arrangement is like opposite of that of resistance of a resistor. So you must be careful with capacitor and resistor. So in series arrangement of capacitor, this is the pattern. Then we want to get the total capacitance. So continue. 1 over CT is equal to 1 over, let's get our C1. We have 2 microfarad plus 1 over our C2, 6 microfarad plus 1 over C3, 3 microfarad, 1 over CT equal to the LCM of 2, 6, and 3 is 6. Then also put your microfarad, 6 microfarad. 6 divided by 2 is 3. 3 times 1, 3, plus 6 divided 6, 1 times 1, 1. 3 divided 6, 2. 2 times 1, 2. So we'll be having, our numerator becomes 6 over 6. Therefore, we have 1 over CT is equal to 6 divided by 6 is what? 1 microfarad. However, recall, we're looking for CT and not 1 over CT. This one is just like 1 over 1. 1 over 1. Okay, let's continue from here. Then we'll reciprocate. CT goes up, 1 comes down, 1 goes up, 1 comes down, it's still the same. So our CT is equal to 1 microfarad. Therefore, 2 microfarad, 6 microfarad, and 3 microfarad joined together will have the same effect as 1 microfarad. Okay, that means we've changed the circuits. The circuit now has a single, the circuit now appears as if we have a single capacitor that has an effect of 1 microfarad. That's what we've done. And with that, we can now tell the charge in that circuit. So we'll bounce back to get the charge. Then the charge, the overall charge in this circuit becomes 1 microfarad. 1 micro. Micro means 1 over 1 million. So retain it there. It's a value. The word micro is a value. So retain it. We can ignore farad because it's just the units. Farad is just the unit. But we retain the word problem micro. It has to be retained. So 1 micro times 12. So the charge becomes 12 microcoulombs. The unit of charge is coulombs. So we've got our charge. Our charge is 12 microcoulombs. So we've gotten the overall charge in the circuit. Q is equal to 12 microcoulombs. Then we can now go back to find the individual voltages, having known the charge. Recall, the main question is to find the voltage or the voltages in the capacitors. Okay, to do that, we can now go back. Okay, to get V1, Q over C1. Then recall, our Q is 12 microcoulombs, 12 micro over our C1 is 2 microfarad, 2 micro. Micro cancels micro. 2 key 12. We'll be having 6 volts. V1 equals to 6 volts. Then V2. V2 will be having Q again over C2. Recall the charge is the same all through because this is series connection. Then we'll be having 12 micro again over, this time we'll have 6 microfarad as the capacitance. Micro will cancel micro. Okay, we ignore the farad, which is the unit of capacitance. Micro cancels micro. 6 divided 12, we'll be having 2 volts. Then lastly, voltage in the last capacitor or the third capacitor will retain our charge. The charge is 12 micro over the capacitance is 3 micro. Micro cancels micro. 3 key is 7, 3 key 12. We'll be having V3 equal to 4 volts. Then the individual voltages are 6 volts, 12 volts, and 4 volts. I want you to observe something. Observe. Okay, go back to the original voltage. Okay, you can see that what out there is 12 volts. 12 volts. Then in series connection, the voltage drops. Recall, in series connection, the charge or the current is the same, but the voltage varies. So there is voltage drop in series connection. Let's see how much voltage that dropped here. In the capacitor 1, we have 6 volts. In the second one, we have 2 volts, 4 volts. Add up, you'll be getting back your 12. 6 plus 2 is 8. 8 plus 4 is 12 volts. That's what we call voltage drop. It's the 12 volts that was distributed amongst the capacitors. And again, recall the logic at the starting. The higher the capacitance, the lower the voltage. And the higher the voltage, the lower the capacitance. Let's observe again. Okay, let's take the highest capacitance. The highest capacitance here is 6 microfarad. And that will have the least voltage. 6 microfarad is having 2 volts. Then the least capacitance will have the highest voltage. 2 microfarad is having 6 volts. This in between. That is what we explained at the starting. That capacitance and voltage are inversely proportional. Okay, then we can now see that the individual voltages are 6 volts, 2 volts, and 4 volts. Going back to the options, we have option D as the best option. Thank you. Please subscribe as we push ahead.